Hi, my name is Shehroz Ahmed, and in this video we are going to cover a topic of IB Math higher level, and the topic is differentiation. So differentiation, by definition, differentiation is basically it's the rate of change of any function. So if we have to find out the rate of change of any function, we will say that we have to differentiate it. For example, let me just write it down first here. The rate of change of a function is differentiation. We can also say that it's a gradient of any function. So gradient of any function is called its differentiation, or we can call it the slope of any function. So basically, let's suppose we have a function whose graph is something like this. We want to find out the rate of change of this particular function at this particular point. So in order to do that, what we do is we will draw a tangent line, and we will find out the gradient of this tangent line. So the gradient of this tangent line will give us the derivative of this curve at this particular point. But in differentiation we will use some certain formulas for differentiation to work out our gradient or slope or the rate of change of any function. So let's start off with some rules for differentiation. Alright, so the rules of differentiation. I'm going to write a bunch of formulas that we will gonna use in taking the derivative of any function. So let's start off with the first one. So if we have a function f of x equals to x to the power of n, then the derivative of this function will become equal to n x to the power of n minus 1. If we have a function of sin x, its derivative will become cos x. Similarly, the derivative of cos x will be negative sin x. The derivative of tan x will be equal to secant square x. So secant square x is basically equal to 1 over cos square x, and the derivative of e to the power of x will be remain same, e to the power of x. The derivative of ln x will be 1 over x, and if we have two functions that are being multiplied and we have to take its derivative, then we will use the product rule. So product rule says that if two functions are being multiplied, and then we can work out their derivative by using this rule. So let's suppose we have two functions u and v, that are both the functions of x, so they are being multiplied, so their derivative will be u prime v plus v prime u. U prime means the derivative of u times the derivative of v plus the derivative of v times the derivative of u. Second one is the quotient rule. So we'll use the quotient rule when the functions are being divided. So if two functions are being divided and we want to find their derivative, so the derivative will be equal to v square in the denominator, then u prime v minus v prime u. So that would be the derivative of these two functions. Okay, now the next thing that we have to discuss is the chain rule. So in the chain rule, it says that if we have to find out the function, if you have two functions dy, and the function y is g of x and the function u is f of x, and we want to work out dy by dx, then it will be equal to dy by du times du by dx. I'll explain this chain rule when we'll solve the questions. So these are the rules that you can use to take the derivative of any function. So these are the most common rules that you're going to use in the exam related question. So that's why I have written these rules. Now the next thing that we have to discuss is the process of finding the equation of the tangent with the help of differentiation. So let me just so by the help of differentiation, we'll try to work out the equation of the tangent on any curve. So let's suppose we have a curve, and the curve has a function of y equals to x square. we want to find out the equation of the tangent at this particular point. So we want to find out the gradient of this tangent. Basically we want to find out the equation of this tangent. So the equation of this tangent will be equal to y equals to mx plus c, and let's suppose this point is 2, 4. So in order to find out the equation of this tangent, we have to work out the gradient and then our y-intercept. So first of all, we'll work out the gradient with the help of differentiation. So what we do is we will differentiate this function, and in the answer we'll put the value of x that will be the x coordinate, that will be 2. Okay, so my function is y equals to x square, so its derivative will become equal to 2x, and I'll put x equals to 2 because we have 2 as the x coordinate. So my derivative will become equal to 2 times 2, that would be equal to 4. So 4 will be my gradient of this function at this particular point. So this is the gradient, or we can represent it with letter m. Now I'll put that into this equation, so it will be like y equals to 4x plus c. Now we have to work out my y-intercept. So we have been given a point onto the function, so it's 2, 4. So what I'll do is I'll insert 2 into x and 4 into y. So I'll get 4 equals to 4 times 2 plus c. So it's like 4 equals to 8 plus c. So c will become equal to 4 minus 8, that would be equal to -4. So my y-intercept will be equal to -4, hence my equation of the tangent to this curve at point 24 will be y equals to 4x minus 4. So that will be my answer. So this will be the equation of the tangent. Now in the next thing that we have to discuss in this topic is the optimization and curves. So let me just erase it, then we'll discuss the optimization and curves. Okay, so in the optimization and curves, let me just draw a simple curve, and then we will do its optimization at different points. So let's suppose this is the curve, and it has some maximas, some minimas, some points. So let's suppose this point is point A, this is the origin, point O, and let's suppose this point is point B. Let's suppose the value over here is 8, the value over here is -2, and this point is C. So what we do is we will have to see the value of the function at these points. We have to see the nature of the value, the nature of the derivative at these particular points, and the nature of the double derivative at these points. Remember that if we write f of x, it will give us the value of the function at that particular point. If we write f dash of x, it will give us the gradient at that particular point, like at x. If we write f double dash of x, it will give us the concavity, whether it is concave up or concave down. Alright, so if we get a negative answer, it means it's concave down, like this. If we get a positive answer for f double dash of x, we will, and if we get a positive answer, it means it's concave up. So it tells us about the concavity. And if we get f double derivative of x equals to 0, it means the concavity is 0, it is neither up nor down. So that point will be the point of inflection. So let's apply these values at all of these points, and we'll discuss the nature. So f of a, so at f of a, at this point the value of y is 0. At f dash of a, f dash of a is basically the gradient of the tangent. So over here you can see the tangent is going up, so we'll get a positive answer. And at f double dash of a, because it is concave down, so I'll get a negative answer. Okay, because you see the trend over here, this curve is concave down like this. So we'll get a negative answer. Alright, now let's see the value of the function, their derivative and double derivative at point -2. So at f of -2, my value of y will be positive. At f dash of -2, the gradient over here at this point, it's a horizontal line, and as we know that the gradient of the horizontal line is 0. So at the f dash of -2 will be equal to 0. Now f double dash of -2, it is still concave down over here, so we will get a negative answer. Now let's see the values at the, this is negative. Now let's see the values at origin, at O. So f of 0, my answer will be equal to 0, like for the actual function. F dash of 0 will be equal to negative, because the gradient at this point will be negative. The gradient of the tangent at this point will be negative. And f double dash of 0 will be also negative, because it still is concave down. Now the next point is quite crucial, f of b. So at f of b, the value of the actual function is negative because it lies somewhere here. So the value of the actual function is negative, but the gradient of at b will also be negative, because if you draw a tangent over here, its gradient will be the tangent will be like this, and its gradient will be negative. But the concavity at this point will be equal to 0. Why? Because this is the point where the graph is shifting from concave down to concave up. So at this particular point, the concavity will be equal to 0, and this point will be called the point of inflection. Now let's see for f of 8. So at f of 8, the value of the actual function is negative. F dash of 8 over here, it's a horizontal line, so the gradient of the horizontal line will be 0. And for f double dash of 8, now it will have concavity in the positive direction. It's concave up, so we'll get a positive answer from here. Or if we get a positive answer, we can say it's concave up. And then the last point, that is f of c. So f of c is equal to 0. F dash of c will be equal to a positive number, because if we draw a tangent at this point, it will give us a positive gradient, so it's positive. Then f double dash of c will have a positive concavity, because this curve is concave up. So this is how we can use the optimization in curves to work out their actual values, their gradients, the nature of their gradients, and their concavity. I repeat, like the simple function just gives us the value of the graph at a particular point. Its derivative gives us the tangent, it gives us the gradient of the tangent or the slope of the tangent, and the double derivative gives us the concavity of the function. So this is it for the concept part. Now let's move on to some exam related questions and let's see how it goes. Alright, so here we have an exam related question for the differentiation. So this question says that let f dash of x is equal to x cubed minus 9x squared plus 24x plus 3. There are two points of inflection on graph of f. Write down the coordinates of these points. So we have to find out the coordinates of the point of inflection. So as I have told you that in order to find out the point of inflection, we will take the double derivative and put it equal to 0. And from there onwards, we'll work out the value of the 2 points. So the function f of x, f dash of x is given x cubed minus 9x squared plus 24x plus 3. So f double dash of x will be equal to the derivative of this function, that would be equal to 3x squared minus 18x plus 24. So I'll put this function equal to 0, and I'll just substitute, like I just insert this value into the calculator, and I'll get the two values of x. So x will become equal to 2 and x is equal to 4. So these are the two x coordinates at which we'll have the 2 points of inflection. Now the next part, it says let h of x is equal to the double derivative of x, f of x, explain why the graph of h has no point of inflection. So the h of x, basically it is equal to f double dash of x. So f double dash of x is 3x square minus 18x plus 24. So I'll write it as h of x equals to 3x square minus 18x plus 24. Now the first derivative of h of x will give us 6x minus 18, and the second derivative of h of x will give us only 6. So when we'll put the double derivative equal to 0, we will see that, because in order to find out the point of inflection, we have to put the double derivative equals to 0. So it'll be like 6 equals to 0. That is not possible, which means we can say that h of x has no point of inflection. So this was quite easy. Now let's move on to some medium level question. Alright, so here's the next question. It's a medium level question, so let's see how it goes. So it says let f of x equals to x square minus 3x plus 2, and the x belongs to a real number. The following diagram shows part of the graph of f. The graph of f crosses the x-axis at these 2 points. Show that f dash of 1 equals to -1. So it's quite simple. We just have to take the derivative of this function, and in the derivative we will put x equals to 1, and we should get -1 as the answer. So f of x is equal to x square minus 3x plus 2. F dash of x will become equal to 2x minus 3. So now I'll put x equals to 1. So f dash of 1 will become equal to 2 times 1 minus 3, that will be equal to 2 minus 3, that will be equal to -1. So -1, we got it. So that's the answer. Now in the next part, it says the line L is normal to the graph of f at P. Find the equation of line L in the form y equals to mx plus c. So they are talking about this line that is normal to P. So let's suppose we draw a tangent at P. So that's the tangent line at P. And we have to work out the equation of the line that is normal to this tangent line. So this blue line, we have to work out the equation of this blue line. So what we have to do is, in order to work out the equation, we need the gradient and the y-intercept. So first of all, what we do is we'll work out the gradient of this tangent, and from this tangent we will get the gradient of this normal because they are perpendicular to each other. So we will find out the gradient. So we need y equals to mx plus c. So in order to work out the gradient, I will put the value of x at P into the derivative of my function. So the point P is 1, 0. So I have just already done it in part A. So this is the gradient of this line at point P. So the gradient of the tangent is equal to -1, but the gradient of the normal line will be equal to, we will flip it and change the sign, so that will become equal to 1. So gradient of this line will become equal to 1. Now I will insert this 1 into my equation, so I'll get y equals to 1x plus c. I have the gradient. Now I have to work out the y-intercept. As we know that point P has x coordinate equals to 1 and y coordinate equals to 0. So in this equation I'll put y equals to 0 and x equals to 1. So it'll be like 0 equals to 1 times 1 plus c. So it's 0 equals to 1 plus c, so c is equal to -1. So the y-intercept of this line will be equal to -1 and the gradient of this line will be equal to 1. So the equation to the normal equation of the line normal to point P will become equal to y equals to x minus 1. So that's the answer. I repeat the working again. So first of all, we have to find out the gradient of the tangent at point P. So this is the gradient of the tangent at point P. And then I have to find out the gradient of the normal line. So what I do is, in order to find out the gradient of the normal line from the gradient of the tangent, we will flip the number, like we'll take its reciprocal and change the sign. So the reciprocal of -1 will be like 1 over -1, and when we change the sign it will become 1. Then I put 1 over here into the equation of the straight line and work out my y-intercept by inserting the value of x coordinate and y coordinate at point P. So I got my y-intercept equals to -1. Then I'll rewrite the equation with the gradient and the y-intercept. So the final equation will become y equals to x minus 1, because the gradient is 1. So it'll be like y equals to 1x minus 1, which will be y equals to x minus 1. Okay, so this part B is done. Now let's see what's next. Alright, so now it says the line L intersects the graph of f at another point R, as shown in the following diagram. Find the x coordinate of R. So this is point R, and we have to work out the x coordinate that will be over here of R. So it's simple. This is the equation for line L, and this is the equation for our function. So we'll equate them together and work out the value of R, the x coordinate of R. So it's like x squared minus 3x plus 2 equals to x minus 1. So it will become x squared minus 3x minus x plus 2 plus 1 equals to 0. So x squared minus 4x plus 3 equals to 0. I'll factorize it, so I'll get the value of one value of x is equal to 1, and the other value of x will be equal to 3. So as we know that the x coordinate of P is 1, so x is equal to 1 will be here, and x is equal to 3 will be here. So the x coordinate of R will be equal to 3. Now it says find the area of the region enclosed by the graph of f and the line L. So we have to work out the area of the region enclosed between these two curves. So for this one we have to use the concept of integration. Alright, so now we have to use the concept of integration. So in the integration, what we do is we have to do the integration from 1 to 3, and in order to work out this area we will do the function of the upper graph minus the function of the lower graph. So the function of the upper graph is x minus 1, the function of the lower graph is f of x. So it will become like this: x minus 1 minus the function of the lower graph, that is f of x, so it will be equal to x squared minus 3x plus 2 dx. Okay, so it will become equal to, I'll just solve it now. So integration from 1 to 3, x minus 1 minus x squared plus 3x minus 2 dx. And I'll simplify it further. I'll do the working over here. So integration from 1 to 3, it's like negative x squared and x plus 3x, that would be equal to 4x, and minus 1 minus 2, that will be equal to minus 3 dx. So now I'll integrate them separately. So the integration of x squared will be negative x cubed over 3 from 1 to 3, these are the limits, plus 4 times x squared over 2 from 1 to 3 minus 3x from 1 to 3. So for this one I'll get minus 27 over 3 minus plus 1 over 3, plus for this one I'll just put the upper limit first, then minus the lower limit. So when I put 3 into x, I'll get 3 squared, that will be equal to 9, so it'll become 9 over 2, minus, then I'll put the lower limit, that will be equal to 1. So 1 squared is 1, so 1 over 2 is simply 1 over 2, minus 3 times the upper limit minus the lower limit. So the upper limit is 3, lower limit is 1, so it's like 3 minus 1. Now I'll just put the whole thing into the calculator and I'll get my answer. So the answer for this is 4 over 3. So the area enclosed by the graph of f and the line L will be equal to 4 over 3. That's the final answer. So this is done. Now let's try a hard level question for differentiation. Alright, so here we have a hard level question. It says a curve is defined by x squared plus 10xy plus y squared equals to 48, and we have to show that dy by dx is equal to this expression. So let's start my working from here. So x squared plus 10xy plus y squared is equal to 48. I'll take the derivative with respect to x on both sides. So dy by dx of this whole thing and dy by dx of 48. So on the left side I will get the derivative of this one, like the derivative of x squared is 2x, plus the derivative of this function. I'll apply the product rule because we have two variables, like we have two functions. The first function is 10x, the other function is y. So I'll apply the product rule over here. So product rule says that if the two functions are being multiplied, their derivative will be u prime v times v prime u. So let's suppose this is u and this is v. So u prime v, that will be equal to, this is u prime 10 y as it is plus y derivative and 10x as it is, plus I'll apply the power rule over here. So it'll be like 2y times y prime equals to 0. Okay, so now I'll take I'll just make y prime as common, and I'll shift rest of the stuff on the other side because y prime is my dy by dx. So it will be like 2x plus 10y plus, I'll take y prime common from here, y prime times 10x plus 2y equals to 0, and my y prime will become y prime times 10x plus 2y will become equal to, this will go on to the right side, this will go on to the right side, so it will become negative 2x negative 10y. Alright, so my y prime will become equal to negative 2x negative 10y divided by 10x plus 2y. Now I'll take this negative sign common from the numerator, so I'll get negative bracket 2x plus 10y divided by 10x plus 2y. So this expression is exactly equal to this expression. So this is how I got my derivative. Now it says find the equation to the normal to the curve at point this much. So it's quite simple. So we just we have found the derivative, so that we will put the value of x into the function into the expression, and we'll get the derivative, and we'll get the gradient of the tangent. So let's find out the gradient of the tangent first of all. So the gradient of tangent to the curve will be equal to negative 2 times negative 2 plus 10 times the y coordinate, that is 22, divided by 10 times negative 2 plus 2 times 22. So I'll just solve it and work out my gradient of the tangent. So this has become equal to negative 9. Now the gradient of the normal will be equal to, I'll just flip it, which means I'll take its reciprocal and change the sign. So it's negative, so the gradient of the normal will be positive, and I'll just swap it, like I'll take the reciprocal, so that will be equal to 1 over 9. So the gradient of the normal is 1 over 9, and now we have to work out the equation. So the equation is y equals to 1 over 9x plus c. So still we do not know what's c. So in order to find out the value of c, we will insert this point into the equation, which means we'll put x equals to negative 2 and y equals to 22. So it's 22 equals to 1 over 9 times negative 2 plus c. So c will become equal to 22 plus 2 over 9, which will become equal to 200 over 9. So the final equation of the normal will be equal to y equals to 1 over 9x plus 200 over 9. When we multiply both sides by 9, I'll get 9y equals to x plus 200, or I can simply write 9y minus x equals to 200. So that's the equation of the normal to the curve. So I'll just write it as 9y minus x equals to 200. The next part is, it says find the distance between the 2 points on the curve where each tangent is parallel to the line y equals to negative x. So in order to do this, let me just erase everything. Alright, so I repeat it again. Find the distance between the 2 points on the curve where each tangent is parallel to the line y equals to negative x. So as we know that we have the equation for the gradient of the tangent over here, and we can get the equation for the gradient of the tangent from here. Then what we do is we'll put them equal to each other and work out the 2 points where the gradients are parallel. So think of it like this. Let's suppose we have a graph like this. There's a line that passes through this graph, and the line is like this. This is the line. So think of this line as y equals to negative x, and think of this curve as our given function. Like, I'll just take it as f of x. So at this point the gradient is negative. Let's suppose the gradient at this point is negative 8. At this point the gradient is positive. At this point, let's suppose again the gradient is equal to negative 8. So what they are asking is to find out the distance between these 2 points where the gradients are same. When the gradients are same, it means that the tangents will be parallel. So at this point, this is the tangent, and at this point this will be the tangent. So these 2 tangents have to be parallel, which means that their gradients should be equal. So we simply have to put the gradients of both the line and the curve equal to each other and work out these 2 points, and then we'll use the distance formula between these 2 points and work out the distance between them. Okay, so this is the main idea. So let's come on to the working now. This dy over dx equals to negative 2x plus 10y over 10x plus 2y, and the derivative for this one will be equal to simply negative 1. So we will put this expression equal to the negative 1 and work out the 2 values of x and y. So it's like 2x plus 10y. In fact, it will be like negative 2x negative 10y over 10x plus 2y equals to negative 1, which is the gradient of this line. Now I'll shift this over on the right side, so it will become negative 2x negative 10y equals to negative 10x negative 2y. This is x over here, so this is y over here. I'll bring x on the left side, y on the left side, and x on the right side, or the other way around. So 10x minus 2x equals to 10y minus 2y. So it'll become 8x equals to 8y. So my x will become equal to y. So I'll write it here. X will become equal to y. Now in the main equation, I'll put my value of x equals my value of y equals to x and work out the values of x. Then I'll put back the values of x over here and I'll get my 2 coordinates, 2 points. So in this equation, I will put y equals to x. So it'll be like x square plus 10 times x plus x square equals to 48. So on the left side, I will have x square plus 10x square plus x square, that will become equal to 12x square equals to 48. Now I'll divide both sides by 12 so that I'll get x square equals to 4. So my x will become equal to plus minus 2. So I'll put plus 2 over here. So my value of one value of y will be equal to 2. The other value of y will be equal to -2. So I'll have 2 points. The first point is 2, 2, and the other point is -2, -2. Now I'll use the distance formula and work out the distance between these 2 points. So the distance will become equal to square root y2 minus y1, so that's be like -2 whole square plus like x2 minus x1 whole square, now y2 minus y1 whole square, so -2 whole square. So once I'll solve it, it will become 16 plus 16, that will be equal to under root 32. So under root 32 will be equal to 4 under root 2. So 4 under root 2 is the distance between the 2 points. So this is how you can use the different derivatives to work out the distance between the 2 points. So this is it for this topic on differentiation. I hope you understood it. So thank you so much for this one.